The loudness level of your master should be determined by the values and intentions of the artist and everyone involved. There's no right or wrong answer here. What I will say is that mastering engineers are very often trying to make a mix as loud as possible while maintaining the impact, clarity, and overall feel of the mix. And this comes with a few challenges. If you want to make your mix louder, you have to turn it up. I know, revolutionary information. Thank you for your time. I appreciate you watching. See you next time. Okay, jokes aside, you can only turn up the mix so far before the peaks of the waveform exceed 0 dB full scale, or 0 dB FS. When this happens in a fixed point digital system, clipping will occur, and this can sound terrible. I'll quickly mention that the 0 dB FS limit is the absolute maximum, but mastering engineers will usually target a peak level below 0 dB full scale for a few reasons. One reason is that even if the meter shows a peak level of 0 dB full scale, there may still be moments between samples where the signal level exceeds 0 dB full scale during the conversion process. To address this, mastering engineers will look at the true peak levels in addition to peak levels. Another reason not to go all the way up to the theoretical maximum level of 0 dB full scale is that most streaming platforms and other delivery formats will include some sort of data compression algorithm prior to reaching the listener. In those cases, leaving even a tiny bit of headroom can go a long way toward preventing distortion during that data compression process. Okay, so let's say you want your final master to have a true peak value of minus 0.1 dB full scale. You turn up the overall level of the mix until the true peaks of the waveform reach that level, but you still want the mix to sound louder. At this point, you could carve out some more headroom with EQ in a particular frequency range, or you could use dynamic range compression or limiting, where the signal level will be reduced when it exceeds a set threshold. But compression and limiting come at a cost. When you dynamically alter the dynamic range of a waveform, you change the shape of the waveform, which results in harmonic distortion. These two things are one and the same. Changing the shape of the waveform, you distort the waveform, and distorting the waveform, you change the shape. There are many different types of limiters and compressors that will behave differently, and they're all potentially useful for various situations. In the world of mastering, engineers often want a limiter that will allow for the mix to be louder without causing excessive distortion, often referred to as a transparent limiter. This is the goal of the limiter within Master Plan, to make the mix louder while maintaining maximum clarity. In fact, the developer behind Master Plan, Sam Fishman, previously joined me for a discussion on this very topic with a lot of visual and audio examples, and I'd really recommend checking out that video if you're interested in learning more. Sam is an amazing teacher, and I learned a lot from that conversation. In Master Plan, there's just one knob for controlling the amount of limiting. If you want it louder, turn up the loud knob. At a certain point, you will start to hear some audible distortion, but that point comes later than expected compared to some other limiters on the market, thanks to Music Hack's proprietary programming. I can't reiterate this enough. Mastering is an art and a science, so use your ears first and foremost, but meters can be helpful. Master Plan allows you to define an LUFS target, loudness units full scale, and will show you where you are in relation to that target with green, yellow, and red indicators. One common reason to use a mixer or compressor in mastering is to gently tame the dynamics of a recording and add some so-called glue. And this is the idea behind the smooth button in Master Plan. But it's not the only reason to use dynamics processing, so experiment. There are times when you want to avoid harmonic distortion, and there are times when you want to embrace it. This is where saturation comes in, which is related to frequency and dynamics. As I've already mentioned, you can saturate a signal with a compressor or a limiter, but you can also use a dedicated saturator plugin to achieve similar results in a more controlled way. You'll see a few options here in Master Plan depending on the type of saturation you're listening for. The thick button engages some analog-inspired saturation, and the tape button emulates the effects of magnetic tape. Again, each one has a slider to fine-tune the amount of the effect. While it might seem limiting to have only a loud knob, pun intended, forgive me, it can actually be very freeing if the behavior of the limiter gives you the results you want without too much fuss. But there are times when a mastering engineer will want a bit more precision. For example, Remember when I mentioned the possibility that a lot of energy in a particular frequency range could impact the behavior of the compressor or limiter? Well, what if you like the frequency balance as is, but want to compress the dynamic range within a particular band? This is where either a dynamic EQ with frequency band dependent thresholds could be helpful, or this could also be an opportunity to use multiband compression with multiple compressors dedicated to particular frequency bands throughout the spectrum. In Master Plan, we can select the multi-switch to turn this limiter into a multiband limiter. When this is enabled, the L, M, and H sliders control the amount of gain reduction in the low, mid, and high bands of your mix. Think of a multiband compressor as a compressor for each of these frequency bands, allowing you to achieve gain reduction within one band without compressing the entire signal. This is one of the biggest tasks of a mastering engineer, using the available headroom in a way that maintains clarity, tonality, and dynamics that are in line with the intention of the music.